Good morning, everyone. Welcome to another episode of Aquarium Online Academy. My name is James. I work in the education department here at the Aquarium of the Pacific in Long Beach, and we're inside one of our exhibits today to talk about food webs. Maybe you've heard of that. Maybe you haven't heard of that. But like every episode, you get to participate. We'd love for you to be able to text us here at the studio at 562-286-1838. My friend Courtney will be able to tell me your questions. So if you have questions of something that we're talking about, or you want to learn more about something, go ahead and text us. If some of our younger viewers maybe have an adult help you out. If you have a question that you're watching and it's not Wednesday morning, but you still want answered, we have an email down here, live at lbaop, that you can, .org, don't forget the .org, that you can email us at so that you can ask us questions if you would like more information as well. Well, now that we've dove into the exhibit, let's think about how things are related. Food webs are part of every natural ecosystem, or habitat even. But what is a food web? What does it really tell us about what's going on? Well, I'm going to step out of the way, and let's make some observations together about our blue cavern exhibit. When we think of a food web, it mostly talks about predator and prey relationships. Who's eating whom? But really, we're also looking at the relationships between all the different living and non-living things. So food webs are going to help us understand how diverse and how well an ecosystem can sustain change. Because sometimes populations change in size. You could have a storm that wipes out a whole bunch of seaweed, and that's going to change the dynamic of that food web for a little while. That's a natural event. But then there's unnatural events that can change the dynamics as well. So we'll talk a little bit more about what food webs are, and we'll build one together on my little document camera. And then we'll talk more about what happens if something changes in that food web. So when we look at any predator-prey food web or food chain relationship, we want to start with the bottom. Not necessarily the floor, although that helps for this exhibit. What do you see on the floor that could help us start understanding where things are getting energy from is gonna happen for us? We have all of this seaweed in here. Now this is replica seaweed. This is not real seaweed. Real seaweed would take a little bit more effort to keep going at this size. And it grows so quickly, we'd have to trim it very frequently so that we can still see everything. So seaweed, or this is called kelp, the giant kelp in here, is the first part of our system. Where do plants and seaweed get their energy from? Is it the nutrients in the soil or the dirt? Well, if you look, our seaweed is on the rocks. Seaweed is actually a special organism, a living thing. It can't grow in sand. It has to attach to a rock. And what that means is that it grows onto a hard surface because it doesn't have roots like a tree or a flower. It has something called a holdfast. So the holdfast is this almost like ball of noodles looking structure that holds onto the rock, and that anchors it down. So it can't really get nutrients from the rock. It doesn't have roots to do that. It gets all of its nutrients from water, but it gets the energy from sunlight. Photosynthesis helps drive this ecosystem, just like most of the surface ecosystems. So think about anything on land or in the water, but not too deep in the water. Sunlight is that very first part of any ecosystem that helps provide the plants in the seaweed and algae energy. So let's go start building my habitat. I am going to draw the sun. Not a very fancy one, just something like if we were all in grade school still. There's my sunshine. Yay! So the sun helps drive that energy. That's actually not dark enough. Let's try this color. Whee! All right, when I draw, I make sound effects. If you don't, that's cool. I'm going to make sound effects, though. There's my sunshine. So in the water, seaweed is what is going to start the next phase. Here is the surface of my ocean. Yay! And I'm going to start drawing some seaweed. I'm going to do it over here on the right side for me. And the easy way to make seaweed is I draw a little squiggle and some noodle-looking triangle structure on the bottom to be my holdfast. And then it gets tougher because I'm not the best at drawing blades. They're almost like leaves on a tree, but there's not a lot of them. And on this kind of seaweed, it has this little bubble right here. It's called a pneumatocyst, and it's a little float that helps the seaweed stand up so it can be long and grow towards the sunlight. Trees have hard structures in their body that help them stand up. If you ever have looked at like firewood, or you've broken open a stick or something, you might see inside is a structure that is kind of stiff and rigid. It helps trees stand up. So they can do that out in the open air, but in the ocean, seaweed needs to be a little flexible. Maybe Courtney will show us seaweed moving around in the ocean while I finish drawing my seaweed. Take a look at this. This is what seaweed looks like out in the open ocean. Does it look stiff and immovable, kind of like the trunk of a tree? Not really. So branches might sway and move around. Leaves can certainly sway and move around. But the trunk of a tree is very rigid. It doesn't want to move. Maybe some trees like palm trees, where tropical storms are very frequent, they'll be a little more flexible, but typically a tree wants to be very upright. So if you wanted to be a tree with me, you'd be like, I'm a tree. But if you wanted to be seaweed, we'd have to all kind of start doing this. So seaweed is very flexible. It is more able to, or more likely to break if a storm comes through, which means the seaweed will kind of wash away. But the cool thing is, seaweed doesn't die if it gets broken off from its middle stalk, called the stipe. If it gets broken off, it's actually still alive. It just floats away and is still providing oxygen. It might still be food for something. It actually still could be a home where something might hide out in the open water. So it creates this little raft of seaweed out in the open water, and fish hide under it. The birds will land on it and rest. So it still is a living part of that ecosystem. It's just not doing this anymore. So seaweed is actually a really, really interesting living thing, part of any coastal habitat like in California. Every major continent has a zone where seaweed can grow, but it needs cold water, and it needs a lot of nutrients in the water. So see how this is really murky and dark? That's normal. We need it to be like this, because all of this murkiness comes from stuff that it needs to grow. All of its nutrients are being absorbed from this murky water. Now, this is the start of our food web. Do you think things eat seaweed? So like, think about a land habitat. Grasses and flowers and trees and, like shrubs and things. Do animals eat parts of those? Yeah. All the different kind of plants on land, something eats a little bit of it. Either maybe they're eating some of the leaves, like there's some animals that eat the leaves, like caterpillars eat leaves. There might be like large herbivores like deer that eat the grasses. So there's different things that eat all the plants on land. But what could eat this? I'll give you a hint. It's not in this video, so don't squint too hard looking for it here. There is a large group of animals that love eating this stuff. They're called urchins. Have you seen a sea urchin before? Maybe not. If you don't live near the coastline, or haven't been to the coastline even, you may not have seen them. I didn't see sea urchins until I moved to California. I grew up in the middle of the continent, so I didn't know what a sea urchin was, except out of a book. But sea urchins are an interesting animal. They love to eat seaweed like this. This is actually one of the blades, or what we would think of like a leaf on a tree. It's sitting on one of these, and it can eat this. It has 5 little teeth, just like we have 5 little fingers. So if you imagine, they're sitting on their face, and they're just walking around munching on seaweed. Here's the little floaty part, the pneumatocyst of a blade of kelp. And the urchin can actually eat just about anything on the seaweed. The blades, the stipe, the main stem, or the main stalk, but they also can eat the holdfast. And they will kind of act like little living lawnmowers and just mow stuff down that they scooch across. Here is a sea urchin on the window. Thank you, Courtney. And right in there, you can kind of see little teeth sticking out. They have 5 little teeth, and it's called Aristotle's lantern. Don't worry about the name of it, but it's a really interesting mouth structure with really big, strong teeth. You can't quite see the full size of the teeth here, but they're really strong to chew through and hold fast. A holdfast is pretty rigid, and they're able to bite through it, so that's pretty interesting for them. Now, they definitely like to eat seaweed and algae. There's other things that do that too. Something called an abalone. Have you heard of abalone before? Imagine a snail with a big curved shell. Now imagine that shell has flattened out kind of like your palm when you hold something down. That is what an abalone looks like. Abalone are like big snails, but with flattened shells like this. They'll eat seaweed, but not the big stuff. They like to eat little stuff right next to where they're sitting. And a lot of abalone don't even have to adventure very far. They just let the seaweed grow near them, and they'll go over and eat a little bit. They don't walk around a whole lot. Abalone are very likely to just sit still. It's called sedentary. They're going to mostly sit there and just chew on a little bit of algae that grows near them. But we do feed our abalone here big pieces of giant kelp. We'll kind of roll it up like a taquito, and we just kind of give them these like seaweed taquitos, and it'll start munching on it and chew it. As long as it's seaweed, they can eat it and digest it, but they don't always eat the bigger things. Now, it's going to be hard for me to draw an abalone on our food web, but I'll do a sea urchin. Sea urchins are a little easier. Okay, I'm going to scooch my picture up just a tiny bit. Now, sea urchins, if you saw, are on the floor. And an easy way to draw a sea urchin is like we're just drawing a pokey little shrub, but you make pokies everywhere, all the way around. I like to draw the longer pokies up top, and then little pokies on the sides. So sea urchins we'll see on the bottom. You might see them up on the rock. So if we saw a big old rock right here, urchins might be up in the rock. And then another piece of seaweed could be sitting right here. Remember, they hold on to the rock. They attach to rocks. So a piece of seaweed could be right there. I'm going to draw this kelp a little faster. Ding, 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 ding. It's going to look like a very, very unhealthy kelp, but it's not. I'm just drawing quickly. So when you remember our food web, so far we've got our things, our seaweed that produces energy from the sun, and then we have something that can eat the seaweed, like abalone and urchins. But what could eat them? I don't know. Whoa. Are you sure this eats urchins? Courtney is emphatically saying yes. Yes, James, how do you not know this? I was making a joke. Of course I know that sea otters eat sea urchins. So sea urchins, they have a lot of defense on their body. When you see a sea urchin, you saw the big pokey spines on their body. Do otters look like they can chew on urchin spines? They have some pretty gnarly teeth, but their teeth are a lot like ours. Their mouth is a lot like ours. So they have the pokey canine teeth. They have the flatter front teeth that are made for biting. And then they have really flat topped molars in the back to mash their food. So if you wouldn't want to eat an urchin like an apple, neither would they. In fact, they'll pull the spines out and then take their favorite rock out of their armpit where you store your favorite rock. Yes, that's where you should store favorite rocks. And then you crack it open. Otters have an extra, like, deep armpit. Their skin around here is just, like, longer than ours, so it's more like a little flap. And they can just hide stuff in their armpit. And that's where they'll store their favorite rocks or shells that they use to crack things open. But otters eat a whole lot of stuff. Not just urchins, not just abalone, but they'll eat crabs and sea stars, maybe an octopus if they can catch it. Octopus don't always like that idea. The octopus are harder for a lot of animals to catch. But otters can eat a lot of different things. Here's a picture of an otter eating a crab. Brought it up to the surface, was able to crack open that shell, and then they use their chest and their tummy like a table, and they just hold their food there and eat from there. Some animals that are in the ocean will eat their food while they're underwater. Otters have to do it up top. And that's because they can't hold their breath for very long. They only hold their breath for about 3 to 5 minutes, about what a person that is swimming might be able to do. So they can't dive for very long, so they have to go grab their food, grab something off the ground. That's where their little grocery store is, basically. Grab their food from the floor, hold on to it, swim up to the surface, break it open, and start eating it. Otters are an interesting animal. So if we look at the chain that we've made, seaweed, urchins, otters. This is one line in a food web. This is a food chain. Now, otters are an apex animal. They are at the top of their food chain. Very few things even try to hunt otter. Some sharks and maybe orca have been observed to eat otters, but not too many times has that been seen. So they have a very wide diet where they'll eat a lot of different things in the habitat, and that's actually very healthy for them. The more variety an animal has in its diet, the more likely it is to survive if that animal is just not around, or if there's not very many, or maybe the seasons change and what animal is more likely to be in the area. So let's add an otter to my drawing. And I'll warn you now, I am not good at drawing otters. I did add a couple of abalone here, these little red ones, because there are red abalone that live here in California. Let's see. They have a round little face. I'm just going to be drawing a very, very sad looking otter because I told you I am not good at this. And they have little flipper feet. Now the otter, I'm going to draw a line, a dotted line to what they eat. They eat abalone and they eat urchins. Remember, we also said they eat crabs, they eat sea stars. So a lot of things go up the chain to an otter. But there's other stuff in a habitat as well as a sea otter that might eat an urchin. There's a really cool fish that we actually have here called a sheephead wrasse. The sheephead is one of my favorite fish. One, because it looks really interesting, and two, because it has an interesting life history. The sheephead wrasse, here it is, the male, has an interesting body. The big males have a very big, wide tail. They have a very large lump on their forehead, it's actually just their skull. It's part of their body. And they have a very big lower jaw. But all of the wrasses, so this is a type of wrasse, all of the wrasses hatch out of their eggs as female fish. All of them. It's not like sea turtles where the temperature of the sand will determine if they grow into a male or a female. All of them start as a female. Now this one is like a juvenile that is transitioning to male. What happens in their environment is if there's not a lot of males around, or if there's not enough of them around to have enough babies with, a few of the dominant females will turn into a male. So once you start to see this black coloring starting on the tail end and the head, that's when they're starting to turn and transition from female to male. And the reason these fish do this is because of reproductive need. Scientists have found out that if this fish has some part of their lifespan as a female fish, and then the next part as a male fish, the number of babies they can have is significantly larger than if they were only female and only male. So this fish adapted the ability to change its sex over its age so that it can have more babies. That helps this fish out a lot. So wrasses all across the planet, every species does this. Now the thing to think about is that not all of the female fish turn into males. Sometimes that doesn't happen, and that's okay. As long as there are enough males for them to have babies, a lot of the females won't transition, and that's fine. They don't need to. So wrasses are interesting, but take a look at the teeth you can see right here. Their teeth are very big. They have large, large teeth that are sharp as well because they will eat sea urchins. And they don't have paws or seashells in their armpits to crack those open. They literally will grab it with their mouth and they'll smack it against a rock. They'll smack it against a rock to crack it open. And as soon as they get it cracked open, they'll eat the insides. So wrasses eat urchins as well. Let's see if I can draw a wrasse. Wrasse, I'm going to start with the tail because they have a big triangle tail. And then they have these kind of like fun little like streamers. I don't know what you call them. Then they have their big bumpy head, big lower jaw, big eyeball, and remember their front half and back half are dark colored, and their middle section is pink. Whee! The sheephead wrasse helps the ecosystem by eating urchins. So there's a few things that live in a kelp forest that eat urchin. That means that we need a lot of urchins to support both the otters and the sheephead. Well, what if there's too few urchins? In this very simple food web we've created, the wrasse doesn't have any other things on here that it can eat. Now, in reality, it does. It eats other fish and it eats other things off the ground. But if this was the only stuff that a sheephead could eat, the only thing they ate were urchins. If there's not enough urchins, they won't be very healthy. Their population goes down. The otter would be okay because the otter has abalone it could eat. Remember, the more variety in the diet an animal has, the better their chances of survival are if something changes in their habitat. Now remember, sea urchins eat the seaweed. What else does seaweed do for all these animals? Let's go back to Blue Cavern really quick. Let's observe our kelp forest habitat here. Blue Cavern, so here's the stuff out in the ocean. Good reminder of what it looks like. Now let's add all the cool fish that we know of in the habitat. Oh, just like that. What do you notice the fish doing around the seaweed? I notice a few of them hiding in it. They're swimming around it. They're moving inside of it. Most of these fish won't eat the seaweed, but there is a few fish that would. If there was less seaweed, or even no seaweed, all these other fish would probably leave the area. Because this is their home. They need the seaweed to hide in or to have babies in. A lot of these fish will lay their eggs in or around the seaweed. So if there's no seaweed, they'll actually leave. There's other animals that would stick around. So the leopard sharks that are found here, they probably would stick around. The sea bass probably would not. That one. And all these other fish would probably just peace out because they need that structure to live in and to hide in and to have their babies in. But that means the sea urchins would still be around. So there's going to be a lot of urchins. So what we've seen in our natural coastal habitats is that areas where either there's too many urchins because the urchin predators aren't around, or areas where there's been like a storm or something happened that washed away a lot of the seaweed, the dynamic, the interactions between all the animals has suddenly changed. So the unnatural event, let's say hunting sea otters, that has happened in the past. Sea otters were almost extinct, especially in California back at the start of the 1900s. There's maybe 50 in California total. Because there's so few otters, the urchin population went boom. Like, well, how can that be? How do sea otters control sea urchins so much? Sea otters are what we call a keystone species. That means they're the most important thing because they have such a huge effect, even if there's only one or two of them. Sea otters eat a ton of food a day. A sea otter, I have a stuffed animal sea otter right here. This is actually close to life size. I mean, this one's a little chunkier than a southern sea otter, but this is about life size. Okay, the head's a little bit bigger too, so proportions are similar. All right, so about this big. This sea otter eats a quarter of its body weight a day. We don't do anything close to that. We might eat about 5% of our body weight a day. So if you're 200 pounds, that's 10 pounds of food. If you're a 100-pound sea otter, they're eating 25 pounds of food a day. Let's like convert that up to a 200-pound person. So normally people might eat like 8 to 10 pounds of food total a day. A sea otter would be eating 50 pounds of food if they were 200 pounds. That's a lot. Have you ever been to the pet store, the really big bags of pet food that are on the bottom shelf, the giant bags, those are about 40 to 50 pounds. That would be the entire weight that a 200-pound person would have to eat per day to equal the volume of a sea otter's diet. That's just not possible. Sea otters eat so much because, one, they don't have any blubber, so their body's constantly losing heat. They use their own metabolism to warm everything up. So because they have no blubber, they have to have a bigger diet. And they do have the fur to help keep them warm, but they have to eat more to stay warm. They live in cold habitats, so they're going to eat a lot of food. And they've adapted the metabolism to eat a lot. So the southern sea otter, like we have here, this one right here, this is a southern sea otter, they might get up to 60 pounds. That means they could eat up to 15 to 20 pounds of food per day in their local habitat. Our sea otters here, because the water's not quite as cold as their local habitat, also because they don't have to forage for food, we go in there and feed them, they eat a little bit less than their wild counterparts. But a wild otter is eating 15 to 20 pounds of food a day. I don't even know what that looks like in urchins, because urchins are not very heavy. But even 5 pounds of sea urchins is a giant bag of urchins. So if you have one sea otter in a kelp forest habitat, the amount of food they eat actually does a lot to balance the ecosystem. And when there's no sea otters, that system is out of balance. That food web, those lines across the web, don't work anymore because the right things are not there in the right amounts. So sea otters do a lot for our habitats. Now the sheephead wrasse, they have a little bit different diet. So if a sheephead is not around, or if there's not very many sheephead, the effect on the ecosystem is still important to look at. Not the same kind of effect as losing an apex predator, an apex predator or a keystone species. Let's look at a sea star real quick. Maybe like a giant spine or ochre star, one of the bigger stars. Now sea stars, I'm actually adding a couple to my drawing real quick. Sea stars are interesting because in certain amounts, they are a super important animal. My sea star looks a little goofy. That's okay. Sea stars eat things that are also on the floor. They're not flying around. They're not swimming around. They're eating things like clams and mussels, maybe snails, maybe some deceased animals. So if an animal passes away, the body sinks to the ground. Sea stars will help eat some of that, along with urchins and crabs and a few other animals. But at the coastline, right where the shore and the water meet, so the beach and the water meet, you get a lot of these animals called mussels. Sea stars love eating mussels. And what they'll do with their tiny little feet is they'll pull open the shells of that mussel, and they spit their stomach in, and then as soon as it's gooey enough, they slurp everything down. But they eat so many mussels that they help clear off surface area of the rocks for more stuff to grow. But one sea star isn't going to do that. One sea star can eat maybe a few mussels a week, but that's not really going to do enough when rocks are covered with mussels. So sea stars become especially important when there's a lot of them around. They become so important when there's a healthy population that they control all the different little things that grow on the surfaces of rocks. They eat those, clears out the way for either more mussels to grow there, or more seaweed to grow there, or other things to land and grow. Sea stars in a high number are really important. And unfortunately, during the 2014 to 16 El Nino period, it was one of the warmest El Ninos we've recorded. Scientists, it harmed a lot of the sea stars. The temperature increase was too much for the sea stars. They all became very sick. And something called sea star wasting disease showed up. Now, it's something like a normal virus that's out in the water, but they were already a little unhealthy because of the temperature, and that made them extra unhealthy. So we lost a lot of sea stars, which means a lot of the coastline, the ratio, the amount of animals, is shifting into an unhealthy level. There's too many things that are growing that are not getting eaten by sea stars. Or because like when the sea otters were almost extinct, there's none of them, there's too many of all the food items, the ecosystem didn't look right. Not like it's supposed to. So our ecosystem should be as diverse and have as much variety as possible. Diversity is what makes an ecosystem healthy. And it doesn't have to be just big stuff. Little stuff is important too. Little crabs, little plankton. So there's tons of plankton in the water too. We need the right amounts of plankton. If there's too much plankton or too little, that changes the ecosystem. So everything in a food web has to be balanced just right. There's a little bit of give. If it's slightly out of balance, it can repair itself. If it gets too out of balance, then it gets all wonky, and people need to step in and help out. So if you're looking for ways to help out, go check out our website. We have lots of different things that the Aquarium of the Pacific is doing to help with conservation efforts to repair the food webs, make sure they're healthy. But you can do your little part just by cleaning up after yourself, sustainable seafood, eating the right things that you need to. Eating healthy actually helps everybody. So do a little bit. Everybody can help out by doing just a little bit. Everybody doesn't have to be perfect and do everything. That's not how that's going to work. So have some fun. I'm glad you were here to learn with us. If you have any lingering questions, email us at live@lbaop.org. We'll have our Spanish language program tomorrow at 9 a.m. We've shifted that from Wednesdays to Thursdays. So if you're waiting for the Spanish language program, that'll be airing tomorrow at 9 a.m. Thank you, everybody, and enjoy the rest of your